Dear students, this topic is basically for the students who are going to appear for JEE or MHCT examination. We have learned different techniques to evaluate limit, but here I am going to talk about how the limit of a function exists. We have learned how to find the functional values. That is, when x values are known to you, you know how to calculate y's value. But when x value is approaching a particular number, how we will come to know the function's value approaches to what number? Sometimes it may not approach to any particular number. That's what we say limit does not exist. For example, let's take an example. Let's say x is approaching 2 and x is approaching x is approaching 2. Here is the number line, 2 year, 3 year, 1 year. If you take the values little less than 2, they are 1.9, 1.99, 1.999, etc. We call it as x tending to 2 minus. So whenever you put a minus above 2, it means near to 2 but less than 2. If x takes value little more than 2, let's say 2.1, 2.01, 2.001, this is known as x approaching 2 plus. So x tending to 2 consists of two methods. One is x tending to 2 minus and other is x tending to 2 plus. X is approaching 2 from the left, x is approaching to 2 from the right. So when x is approaching from left, we call left hand limit. X is approaching through right, we call it a right hand limit. Let's take the case of f of x equal to x square plus 1. Suppose I put x square's value as 1.9, x values are 1.9, 1.99, etc. That means x squared plus 1's value I am calculating by substituting these values. So I will be getting a number. 1.9 square will be a number near to 4. Added 1 to it, I'll get 5. 1.99 square is near to 4. Added 1, again 5. That means when x takes these values, the value of x square plus 1 will always approach 5. So I write limit x tending to 2 minus x square plus 1 is equal to 5. Again, when I put x value as 2.1, 2.01, 2.001, in that case also, I will get x value as x square plus 1's value as 5. So we say the left hand limit of the function is 5, right hand limit of the function is 5, hence my conclusion is limit x tending to 2, x square plus 1 is equal to 5. So here the limit is 5 and limit exists. Imagine the left hand limit and right hand limit are different, then we say the limit does not exist. I'll give you an example for this question. F of x is 3x plus 1 for x greater than 1. What does that mean? Whenever the value of x is a number more than 1, you should apply this formula to get the y coordinate. When x value is less than 1, you must apply the second formula. For example, if I want to calculate f of 0, 0 is a number less than 1, then I must apply this formula, 2 into 0 square plus 1. That will be my answer. Suppose I want to calculate f of 5. 5 is a number more than 1. Therefore, I must apply this formula. So 3 into 5 plus 1, that is equal to 16. So this is the meaning of this function. When x value is more than 1, use this. When x value is less than or equal to 1, use this formula. That is the meaning. Now, I need to calculate limit x tending to 1 minus f of x, limit x tending to 1 plus f of x, and finally what is the limit x tending to 1 f of x. So when x is approaching 1 minus, which means the value of x is point, we have number line, just have a look at the number line, 1 year, 0 year, 2 year. Now x is tending to 1 minus means the value of x is 0.9, 0.99, etc. That means if I ask you to calculate f of 0.9, I will be substituting in the first or second. Naturally, x value is less than 1. When x is less than 1, this is a function that we need to use. So I will write this as limit x tending to 1 to x square plus 1. Although x written 1 minus, it means it is coming closer to 1, but the value of x is less than 1. Because the value of x is less than 1, we need to apply this formula. And your answer became 2 into 1 square plus 1, that became 3. So when x is approaching 1 through the lesser values, 0.9, 0.99, 0.99, etc., in that case, the value of the y coordinate will be near 3. when limit x tending to 1 plus f of x, that means the value of x is now 1.1, 1.01, etc. These are the values x will be taking. So x value is more than 1. So we need to take the second formula. X value is more than 1. We must take this second formula. So I can say limit x tending to 1. We don't write again 1 plus once you replace the formula. So 3x plus 1. That is 3 into 1 plus 1. You will get 4 as answer. Which means the value of x is little more than 1. The value of the y coordinate will be 4. So left hand limit is 3. Like right hand limit is 4. Therefore what I can say, left hand limit and right hand limit are not equal. Not equal, which implies limit x tending to 1 f of x does not exist. So if the left hand limit and right hand limit are not equal, then we will say that the limit does not exist. Left hand limit exists, which is 3. Right hand limit exists, which is 4. But limit x tending to 1 f of x does not exist in this particular case. Look at left hand limit of x tending to 0, 1 by x. Right hand limit of x tending to 0, 1 plus x. And the limit of the function 1 by x. So what is the meaning of this x tending to 0 minus? The x values are, this is a number line, 0 here, 1 here and minus 1 here. Which means x value is minus 0.1, minus 0.01, minus 0.0001, minus 0.00001, like this. X value goes on like this. What happens to 1 by x? 1 by x will be 1 upon minus 0.1. That is equal to minus 10. What will be in the second case? When x takes this value, what will be the value? 1 upon minus 0.001. That will be minus 1000. You will notice that as the number of after the decimal number of zeros are increasing, that many number will keep on increasing in the right hand side. So in case of this, it will be 1 upon minus 0.001 will be minus 1, 2, 3, 4. So if you continue in this process, this is looking larger, 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 but with a negative sign. Numerically large with a negative sign. So I can conclude that when x is tending to 0 minus, this will become minus infinity. So your answer for limit x tending to 0 minus 1 by x will be minus infinity. Let's now take the next case when x tending to 0 plus. When it is 0 plus, I can assume this negative sign will go away. Naturally here also negative sign will go away. And naturally here it will be a very large number, positive large number. So this will become plus infinity. So left hand limit is minus infinity, right hand limit is plus infinity. Therefore the left hand limit and right hand limit are not equal. So limit x tending to 0, 1 by x does not exist. Although the limit is infinite, but one goes to the negative side of infinite limit, other goes to positive side of limit. So we can say the limit does not exist. This is not only true for this, any function with the denominator becoming 0. Let's say x plus 1 upon x minus 1. What will happen here? When x tending to 1 plus, this will go positive infinity. When x tending to 1 minus, this will become negative infinity. So the limit does not exist. So whenever the denominator alone becomes 0, it will be always the limit does not exist. This is a pattern. But if you notice limit x tending to 1, x plus 1 upon x minus 1 the whole square. Now what will happen? The denominator will be always a positive number because of the square. So the limit will be infinite. So this function, we will not say limit does not exist, we will say limit is infinite. Here there is no, or both the left hand limit and right hand limit will approach infinity. Infinity is not a real number. So here also we call it as limit is infinite. We will discuss about a new function which is known as greatest integer function, which is something slightly different from the usual functions. So let's have a look at it. Greatest integer function is denoted by a square bracket. Let's find out the value of any integer. Let's say x takes value 1.02. We read it as the greatest integer not greater than 1.02. Where is 1.02 comes? Let's say this is 1.02. What are the integers which is not greater than 1.02? All of them, minus 2, minus 1, 0, 1, minus 3, minus 4. All of them are integers not greater than 1.02. Out of that, the greatest is 1. So the greatest integer not greater than 1.02 is 1. What did I say? The integers which are not greater than 1.02 are minus 3, minus 2, minus 1, 0, 1. Out of that, which is the greatest? That is 1. So very easy to look at the number line and decide. What is the greatest integer of 1.8? 1.8 comes here. What are the integers not greater than 1.8? 1, 0, minus 1, minus 2, etc. Which is the greatest of it? 1. So whenever a number lies between 1 and 2, any numbers, indeed the greatest integer will be the lower number 1. So what will be the greatest integer of 1? 2.5. 2.5 comes here. Which is the integer less than 2.5? That is 2. Again, greatest integer of, let's say, 0.8, 0.3. 0.3, the greatest integer that is less than the integer which is below 0.3 is 0. Therefore, our answer is 0. Greatest integer of minus 1.2. Where does minus 1.2 comes? Minus 1.2 comes over here. So what is the lower integer? Minus 2. So greatest integer means the number, first find out 2.5 lies between two integers. What are they? 2 and 3. The greatest of that is, the lower one is 2. So that will be your answer. 0.3 lies between which two integers? 0 and 1. Which is lower one? 0. So you will be taking lower one, 0. Now what about integer of an integer? Then the number itself. Integer of 2 is 2 itself. Integer of 3 is 3 itself. Integer of 4 is 4 itself. So if the number lies between two integers, the lower number is the integer of that number. We are going to calculate the functions in limit in these two cases. So every time when we talk about x tending to minus 3 minus, look at the number 2 here, 3 here, 4. So 3 minus means a number little less than 3, like 2.999. So integer of 2.99 is nothing but, integer of this number is nothing but 2. So integer of any number which is less than 3 will be 2. Integer of any number more than 3 but near to 3. More than 3, near to 3. Like 3.1. Integer of 3.1 is 3. So what do you notice? Left hand limit is 2, right hand limit is 3. They both are not equal, so it does not exist. So left hand limit and right hand limit are different. In that case, what is my conclusion? Limit extending to 3, integer of x does not exist. Now let's have a look at this case, which is 1.5. 3 by 2 means 1.5. Let's have a look at it. This is 0, this is 1, this is 2. 1.3 by 2 comes here, which is 1.5. Let's take a number little less than 1.5. Let's say 1.4. Integer of 1.4, integer of a number near to 1.5 but less than 1.5 will be 1 itself. If I take a number little more than 1.5, little more than 3 by 2 plus means little more than 1.5, let's say 1.6. What is the integer of 1.6? 1.6, lower number is 1, that is also 1. So by conclusion, the left hand limit is 1, right hand limit is 1. So limit extending to 3 by 2, integer of x is 1. So what have you understood from this two example? If the number, the x is tending to an integer, the limit will not exist. If x is tending to a non-integer, a fraction, a decimal one, will give you a limit. It will be the lower limit of that integer. For example, limit x tending to 1.6, integer of x. 1.6 is a number lying between 1 and 2, so your answer is 1. Limit x tending to 3.5, integer of x. 3.5 is a number lying between 3 and 4, the lower one is 3, so your answer is 3. Limit x tending to, let's say, 2, integer of 2x. Now x is an integer number. So 2x will become, when x is 2 here, this will become 4. So I can say 0, 1, 2, 3. If I put, let's say 1.9, so if I put 2 into 1.9, it is 3.8. 3.8 integer. Now take the integer of 3.8, it is going to be 4. So limit extending to 2 minus will give me 4, integer of 3.8 is 3. So limit extending to 2 minus 2x will give me answer as 3. Limit extending to 2 plus integer of 2x. 2 plus x means it is 2.1. 2.1 if I multiply with 2, I'll get 4.2. Integer of 4.2 is 4. So left hand limit and right hand limit are not equal. So limit of integer, so I can say like this, limit extending to 2, integer of 2x does not exist. Let's take another example. Limit extending to 3 by 2. Limit extending to 3 by 2, integer of 2x. Again, when I put x as 3 by 2 here, left hand limit. Let's take limit extending to 3 minus 3 by 2, 2x. So when I substitute here, I'll get a number 3. Because it is 3 by 2, 2x is equal to 2 into 3 by 2, which is a number 3. But it is 3 minus, so it will be less than 3. So less than 3 means somewhere 2.9, and integer of that 2.9 is 2. Again, limit extending to 3 by 2 plus 2x. When I put this number, it will be a number little more than 3. Integer of a number more than 3 is 3. So again, left hand limit and right hand limit are not equal, so limit does not exist. So my conclusion, if this becomes an integer on substituting this limit value, then the limit will not exist. If it doesn't become an integer, the limit will exist and it will be the lower number. For example, limit extending to 1.7, 2x. So when I put 1.7 here, I'm not getting an integer. I'm getting 2 into 1.7, that is 3.4. If I'm getting 3.4, it is a fraction. And the integer of that number will be the lower number, so 3. So here the limit will exist, but limit extending to 1.5, 2x does not exist. So if this number turns to be an integer, the limit will not exist. On substituting this number, if this number turns to be a fraction, the limit will exist and it will be the lower number, lower integer of that number. That means that particular number 3.4 lies between 3 and 4. So your answer will be the lower number 3. That's how you have to quickly answer. So you can easily now tell me the answer. Let's try one by one. Limit extending to 2, 5x, x by 5. So you will put x as 2 here, 2 by 5. Is it an integer? No. So limit will exist. And what will be the answer? 2 by 5 is a number between 0 and 1. So your answer is 0. Now let's have a look at another one. Limit extending to 2, let's say x by 2. When I put x as 2 here, I get 1, I get an integer, does not exist. Another example. Limit extending to 3, let's say I have 2x. When I'm putting x as 3 here, I'm getting 6 as the answer. So it is an integer. What we are getting here is an integer, so it does not exist. Limit extending to 3, x by 3. I'm going to replace x by 3 here. So I'm getting an integer as answer here, so it does not exist. So when you substitute the limit, if you are getting integer as answer, then we can say the limit will not exist. Now let's have a look at this one. When x is tending to 4, whether the integer of this function, when I put the square bracket, it is means integer function. It should be clearly mentioned in the question whether it is integer function or not. When x is becoming 4. So log 4 to the base 2, which is log 2 square to the base 2, which is 2 log 2 to the base 2, which is 2. So you are getting an integer here. You are getting an integer here. So it does not exist. Now let's have a look at this one. Log of 2 to the base 4, which I can write as log of 2 square. 4 is 2 square, which I can write as half log 2 to the base 2, which I am getting the answer as half. So 1 by 2 means 0.5, which lies between 0 and 1. So this limit will be 0. The log x to the base 4 when x approaches 2 is half. So half is a number which is not an integer, so limit exists. And half lies between 0 and 1. The lower integer is 0, hence the limit is 0. So I will replace x by 3. So log 3 to the base root 3. That is log 3 raised to half, which will become 1 upon half log 3 to the base 3, which will become 2 log 3 to the base 3, which becomes 2. So the value of this will be 2. 2 is an integer. Because 2 is an integer, does not exist. This is how we can calculate the limit. If I look at next one, limit x tending to, let's say, pi by 6, 2 sin x. Integer of 2 sin x. Pi by 6 means 30 degrees. Sin 30 is half. So when x is pi by 6, 2 sin pi x will be 2 sin pi by 6. That is 2 into 1 by 2, we get 1. This happened to be an integer, so it does not exist. Another example. Limit x tending to pi by 4. 2 sin x. So what is the value of 2 sin pi by 4? That is 2 into 1 by root 2, which is root 2. Root 2 is approximately 1.4, which means root 2 lies between 1 and 2, which means the lower integer is 1. So the limit of this function is 1. This is how you can calculate. Limit x tending to, let's say, 1, modulus of x. Okay, let me take limit x tending to 0. Limit x tending to 0. That means there are two possibilities. One is left hand limit x tending to 0 minus modulus of x. Limit x tending to 0 plus modulus of x. When x is a number near 0, that means x values are negative numbers. When you take the modulus of that, let's say I put modulus of minus 0.0001's modulus. Naturally, it will be 0.0001, a positive number, but it will be very near to 0, so the limit happened to be 0. Whenever a number is closer and closer to 0, when x is such a small number, modulus of x will be very, very small, but positive number, I'll get 0. If suppose x is tending to 0 plus, limit x tending to 0 plus, that means I'll get 0.0001's modulus. I'll get the same number 0.0001. Positive, any positive numbers modulus is that number itself. So this also will tend to 0. So my conclusion is limit x tending to 0 minus is 0, limit x tending to 0 plus is also 0, hence my answer is 0. Now let me have a look at limit x tending to 0, let's say x upon modulus of x. X upon modulus of x. In this case, let's have a take both the cases. First case, let me take limit x tending to 0 minus x upon modulus of x. 0 minus x is a negative number, so this will be also a negative number, and this will be a positive number, so naturally the answer will be negative. Modulus of any number is positive, x is happen to be a negative number, so answer is going to be negative. Imagine I put x as 0.01 with a negative sign. So numerator will be minus 0.01, denominator will be minus 0.01's modulus. Numerically they will have same value. So your answer will be minus 0.01 divided by 0.01 because modulus negative went away. But numerically, because they are negative same value, so you will end up with minus 1. So numerical value both will be same, so they will cancel and become 1. They are opposite sign, so it become minus. So hence it will be minus. Let's have a look at limit extending to 0 plus. Now both of them are same sign. X is also positive, modulus of a positive number is also positive, so naturally this will be positive. Numerically they will be same, so they will cancel and become 1. So left hand limit will give you minus 1, right hand limit will give you plus 1, so limit does not exist. If the left hand limit and right hand limit are not equal, the limit of this function does not exist. So that's how you have to always think. So limit extending to 1, modulus of x minus 1 will be 0, but limit extending to 1, x minus 1 upon modulus of x minus 1 does not exist. So this is what you have to remember. Whenever the term inside the bracket is tending to 0, so and if you take the number upon its modulus will not exist. But if it is not becoming 0, suppose I ask you limit extending to 2, x upon modulus of x, it will be 1 because 2 is a positive number. So this is positive, this is also positive. So it will give you 1. Suppose I ask you limit extending to minus 2, x upon modulus of x. Now what will happen? Whether left hand limit or right hand limit, this will be always negative. So your answer will be minus 1. Because this is a negative, if you take any number, minus 2 here, minus 1 here, minus 3 here. If you take a number here, that will be negative. So that will become negative upon positive will give you negative. If you take a number here, that will be also negative. So negative upon positive number will give you negative. Both the cases you will get minus 1. If you take a positive number, let's say 2 here, if you take any number in the neighborhood of 2, both the cases will be positive upon positive will give you 1. But what happens in the neighborhood of 0? Neighborhood of 0, this is positive and this happen to be negative. So when you divide a number in the neighborhood of 0, one side you will get negative and other side you will get positive. For example, if it is less than 0, you will get negative. If it is more than 0, you will get positive. That's why only in 0 alone the limit will not exist. All other places the limit will exist in case of x upon modulus of x. I look at this function, limit extending to 0, modulus of sin x upon x. We know that limit theta tending to 0, sin theta upon theta is 1. In this case, when theta can be in first quadrant, the 0, the 90 degrees, the 180 degrees. Sorry, minus 270 degrees. 270 degrees or minus 90. It's better to say minus 90. This way, if you rotate it plus 90, if you rotate to minus 90, so there are two possibilities. Limit x tending to 0 plus, that means in the first quadrant. And limit tending to 0 minus, that means in the fourth quadrant. This is a 0 plus and this is 0 minus. So the angle will be 0 plus will be in first quadrant and 0 minus will be in the fourth quadrant. Let's have a look at it. So first I'm going to talk about 0 minus. Modulus of sin x upon x. Now you can see x is a negative number. Sin x will be negative because in the fourth quadrant. But its modulus will be a positive number. So you will get answer as minus 1. Why do you get 1? Because sin theta upon theta, if the value of the angle is near to 0, sin's value and the angle's value will be almost equal. That's why we get 1 as answer. When you take limit extending to 0 plus modulus of sin x upon x, this is positive number because of modulus. This is also positive number. So you will be positive upon positive and you will get 1 as the answer. So the left hand limit and right hand limit are not equal, so limit does not exist. So always you have to look, what is the sign? If both are same sign, then you will be getting 1 as the answer. Both are opposite sign, you get minus 1 as the answer. Therefore my conclusion is limit does not exist. Now let's have a look at root of a number. Let's say root of 5 square. Root of 5 square is root of 25. That gives you 5. Which means this case you can cancel. Let's look at this root of minus 5 square. That becomes root of minus 5 when you square, it becomes 25. When root of 25 is 5. What have you noticed here? This is not true here. So in this case, root of 5 square and square root cannot be cancelled. So whenever we have square and square root arises, the answer that you are going to get is always positive. Whatever the value that you get may be inside the square, this may be positive or negative, you will get always a positive number. So root of a square is modulus of a. It is not, do not write root of a square is equal to a. This is true only if a is positive. If a is negative, root of a square will be modulus of a, which is modulus of if a is a negative number. So this statement, this root of a square is always positive. So when I write like this, root of sine square upon x, it is nothing but limit x tending to 0, modulus of sine x upon x. Reason behind, when x is 0 minus, this will be a negative number, and when it's 0 plus, it will be a positive number, because as I told you before, this limit does not exist because, what is the reason? Limit x tending to 0 minus modulus of sine x upon x. Now x tending to 0 minus, x lies in fourth quadrant. X belongs to fourth quadrant. Therefore, sine x will be negative. So this will become minus. Because x is negative, modulus of sine x is positive, but x is negative, you will get negative answer. So minus 1 will be your answer. When it is limit x tending to 0 plus modulus of sine x upon x, now both of them are positive, so plus 1 will be your answer. So left hand limit and right hand limit are not equal, so the limit of this also does not exist. So in this example, you must remember that whenever I have root of a perfect square, I should write it as modulus a and do not write it as a alone. So you should always put the modulus. After putting the modulus, then you have to check about left hand limit or right hand limit are equal or not.